This is 99% Invisible. I'm Roman Mars. There's a subgenre of kid videos on YouTube that are named things like My Toddler Masters the iPhone and Baby Works iPad Perfectly.
Hi, this is Bridger. Say hi, Bridger.
Hey, Bridger.
He is playing with the iPad and he just turned 2.
Some of these video titles also say things like must see in all caps. But like all things that say must see, it's not true. You can totally do without seeing these videos.
Oh, you want to change the background to blue?
Mostly it's a bunch of babies drooling and poking at iPhones. The thing is though, these tiny drooling iPhone pokers are actually able to execute commands, open up programs they want to use, play games, and take photos. And despite what we parents believe, it isn't because our kids are smart.
You're so smart, Bridger.
Well, some of them might be smart. Bridger seems pretty smart.
That's producer Louisa Beck.
But mostly, it's just that iPhones, actually computers in general, are just incredibly easy to use.
Today's user interface in the modern computer is what I call grunt and point. It's very primitive communication, so that's why I call it grunts.
That's Christina Engelbart. Her father, Doug Engelbart, had a vastly different vision for what computers could be than these super simple devices that toddlers can use.
Doug Engelbart's vision required us to actually learn stuff.
In order to really push the envelope of human effectiveness and intellectual effectiveness, you don't want to be confined to just a very small vocabulary of grunts and clicks. So you want to actually have a full language.
Doug Engelbart was a pioneer in his field, and his main goal wasn't to make computers that toddlers could use. He wanted them to be as powerful as possible, and imagined that if we took the time to learn how to use our devices, if we became fluent in their language, their potential to make us smarter, more efficient humans would be huge.
Doug Engelbart, who passed away in 2013, grew up during the Great Depression on a small farmstead near Portland, Oregon. He later served as a radar technician in the Navy during World War II. He was a West Coast optimist who studied at UC Berkeley and was influenced by the 1960s counterculture. When he later had his own lab, he made his researchers attend personal development seminars where they talked about feelings and life philosophies. In his time, Engelbart's ideas were lofty and unique and relentlessly idealistic.
My father was considered a kook, and he was not widely respected or even widely known.
Engelbart's name may not be widely known, but if you work at a computer, you use one of his inventions every day.
I don't know why we call it a mouse. Sometimes I apologize. It started that way, and we never did change it.
That's Engelbart showing off his revolutionary invention in 1968, the computer mouse.
Engelbart's mouse had 3 buttons, though he would have added more if he'd been able to fit them. And it was meant to be used in conjunction with another device called a key set, which looked like a small 5-key piano, 1 key for each finger, and was controlled by your left hand.
This device over here is unique to us, and we always have to justify and explain it. It provides for you the one-hand equivalent of what you can do with a keyboard.
The idea was that with your left hand on the key set and your right hand on the mouse, you could do almost everything that you would need to do without moving your hands back to the keyboard, including typing out characters of the alphabet and executing shortcut commands. But beyond the shortcut commands that we use now with a keyboard, Engelbart's mouse and key set opened up a larger vocabulary that we could use when communicating with a computer.
So we could do like my dad did. Put your left hand here.
I visited Christina Engelbart at the Doug Engelbart Institute, which is an educational and consulting institution that aims to promote his ideas. It's housed at Stanford Research Institute in Menlo Park, the very place where her father and his collaborator Bill English built the first prototypes of the mouse in 1964. Christina showed me the key set, and I tried to get a feel for what it would be like to type my name with it.
Okay, so there's 26 letters to the alphabet, and what's the first letter?
A.
Yeah. So what number would you use?
So A.
I mean, you can guess, yeah.
Basically, each finger on the keyset is assigned a numerical value. My thumb is assigned a 1 and my pointer a 2. So if I want a 3, I need to press down my thumb and pointer because they add up to 3. Then we map numbers to letters. So C would be my thumb and my pointer.
Exactly.
Wow.
Yeah,
it
is
like playing the piano, like just the chords on the piano.
Right. Physically, it requires that much.
With each letter mapped to a number, A being 1, you can imagine that it gets harder once you reach the middle letters of the alphabet.
Yeah, I have no idea off the top of my head what number of the alphabet O is.
Right. Well, there's a chart you can hang up next to your desk to reference what number each letter is. But the point is, all of this takes some practice. Still, I could imagine how, with a lot of repetition, you could get fast at using the keyset. Doug Engelbart felt his mouse and keyset would allow us to communicate with computers more fluidly and efficiently.
Even though it sounds pretty hard to learn.
It wasn't as if Engelbart was against user-friendly devices, but he just believed that if we were willing to put time into learning computers, they could do so much more for us. He felt they could help us communicate and collaborate to become better humans and more effective problem solvers.
So that meant, how can you make humans in groups and organizations be dramatically more effective? How effective can you make them? Is there a limit?
And maybe the idea that computers could help us collaborate doesn't sound that crazy now, but Engelbart was working at a time when most people thought of computers as giant calculators. Their purpose was to automate tasks.
And in my father's paradigm, why would you ever automate how you do things now? A computer affords a whole new way of working. What way would you work if you weren't limited to the old technology?
In the early 60s, Engelbart got funding to start his own lab where he could experiment with all of his ideas. His lab hosted one of the 3 centers of the ARPANET, which is one of the key ancestors of the internet.
So Engelbart actually helped invent the internet.
And throughout the 60s and early 70s, his group built entire online collaboration systems that included video conferencing and collaborative text editing. Here he is presenting those things in what became known as the mother of all demos.
I need to know what terminal you're on, Bill.
13.
Okay. I'd like to have him see my text. And so this special thing, if I label 13, will switch over, so in his display he sees my text, so I'll execute it, and sure enough it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it.
The reason people call it the mother of all demos is that in it, Engelbart showed the world so many revolutionary ideas. The mouse, of course, but also a bunch of things that didn't catch on until decades later. At the time, most people hadn't even heard of personal computing, let alone the internet. And here was Doug Engelbart demonstrating the ancestors of tools like Skype and screen sharing and Google Doc editing in the 1960s.
Despite all of this, by the early 1970s, Engelbart's lab ran out of funding to continue his research. Much like his 3-button mouse and keyset, his other ideas were seen as interesting but complicated and not particularly marketable. And meanwhile, another computer visionary had entered the scene. One that, unlike Doug Engelbart, you've probably heard of. A guy by the name of Steve Jobs.
Steve Jobs was never satisfied with the first or the second or even the 10th pass at making something simple.
That's Larry Tesler, who worked at Apple from 1980 to 1997 as VP and chief scientist.
No matter how simple you made it, he would come and say, "That's pretty good, but I think you can make it simpler than that." And then he would leave us like, "Well, how?" Once in a while he would make a suggestion, but usually he just walked away, and we had to figure out a way to make it simpler.
One thing Jobs wanted to simplify was Engelbart's mouse and keyset combo. Jobs had first seen the mouse and keyset at Xerox PARC, which was a cutting-edge computing research facility at the time. In the 1970s, when Engelbart's lab started to disband, a lot of Engelbart's researchers and some of his prototypes ended up at Xerox PARC.
Jobs found the mouse and keyset intriguing but entirely too complicated to use. He dismissed the keyset altogether. And in 1980, Apple's Larry Tesler wrote a memo to Apple employees saying that the mouse Apple was developing would only have one button. Throughout the years, Apple held on to its one-button mouse, even as competitors developed two-button mice.
And Steve was very attached to it.
Apple never even considered including Engelbart's KeySet companion to the mouse. It was too costly, clunky, and complicated to learn.
At Apple, we wanted people to come into the store, look at the software, try it out, figure it out in the first few minutes, and plunk down a credit card and take the computer home. And it wasn't okay to say, well, take it home and work on it every day for several hours a day, and in 6 months you'll be really good at it.
And suddenly, computers were for everyone, even Bridger.
Hey, Bridger.
You know, that's beautiful. That's a beautiful thing. And that it's helped a lot of people.
That's Christina Engelbart again.
The problem is when that's the whole mission.
Christina thinks that when we prioritize simple, user-friendly devices over more complex, learnable ones, we limit ourselves, and we might miss out on important ideas. And for a while at least, Steve Jobs did exactly that.
When Jobs showed Engelbart the brand new Apple computer, Christina said that her dad responded like this.
My dad said, well, gee, what about communication to the networking?
In other words, document sharing, video chatting, and all the collaborative stuff that Engelbart was excited about. For Engelbart, collaboration was the most important thing. Computers needed to connect. But for Jobs, at this point anyway, simplicity was key.
And Steve said, oh, no, you don't need that. Everything you need should be on your desk. A personal computer is all you need.
At the root of Apple's success lies the world's first personal computer. The Apple II, small, inexpensive, simple to use. The first computer an individual could take out of the box, plug in, and run. Bringing computing down to a personal level. One person, one computer.
That was taped from a 1983 promotional video for Apple. Here's Jobs himself talking about missing the importance of networking when it was first demonstrated to him at Xerox PARC in 1979.
They had over 100 Alto computers, all networked, using email, et cetera, et cetera. I didn't even see that. I was so blinded by the first thing they showed me, which was the graphical user interface. I thought it was the best thing I had ever seen in my life.
Of course, Jobs eventually came around to networking, but I take Christina Engelbart's point. As a designer, being married to simplicity could be limiting, and we might also be limited by simplicity as users.
The example my dad used to like to give, and I think this is really appropriate, is the difference between a tricycle and a bicycle. So anybody can get on a tricycle, especially if you see somebody else ride it, you can just get on and ride it. You don't need any special training. You just kind of do it and figure it out. But that's fine if you're just going to go around the block a couple of times or something.
If you're trying to go up a hill, a tricycle is a pretty bad way to go. You want a bike with gears, and you'll learn how to balance and steer it and change gears because it gives you a lot more power. You can cover a lot more steep ground.
A lot of people have made the point that by dumbing down computers so much that it's easy for anybody to learn, we've made it so that most people don't go to the trouble of learning something that could give them more leverage, more power with their computer. And I think that's a fair criticism.
That's Larry Tesler again. He agrees that early on, Steve Jobs overlooked networking, but he also thinks that Jobs was right to push for simplicity.
If you make it, as we did at Apple, so that just about anybody can do things that they do every day on a computer or on a smartphone, then you're giving them the only opportunity that they'll probably ever have to benefit from that power.
Doug Engelbart might look at the world now and say, they're all on tricycles. They should be on bicycles.
The thing is, our tricycles have gotten pretty awesome. They've become so powerful and so well designed that we're actually able to get around without ever learning how to balance on two wheels or shift gears. Maybe that's the world we're living in today, one where a lot of Engelbart's ideas have come to fruition and almost anyone can access them, including you and your mom and your granddad, and yes, pretty soon, your drooling iPhone poking toddler.
But I think Christina would say there's still more we could learn, and our simple interfaces have sort of hidden that path from us. They've hung a curtain over the complicated stuff to keep us from having to face it, and in doing so, they keep us stranded in grunt and point land.
My dad always said, well, sure, easy to learn, easy to use is fine for the beginner, but once you've used something for a year or 2 or 5, why would you sit down and use the computer the same way you did the very first day you came in? That's ridiculous. You need to have a clear, streamlined path for advancing into a much more sophisticated, holistic way of interacting with the computer.
Maybe the question is, what kind of users do we want to be? The best design may not always be the one that's user-friendly at first sight. It might be the one that allows us a degree of virtuosity if we think investing the time is worth it. Or in other words, it's the one that helps us switch from tricycle riding to bicycle riding, so that if we want to, we can go up some really big hills.
99% Invisible was produced this week by Louisa Beck with Katie Mingle, Sam Greenspan, Avery Trufelman, and me, Roman Mars. We are a project of 91.7 KALW San Francisco and produced out of the offices of ArcSign, an architecture and interiors firm in beautiful downtown Oakland, California. We consulted a ton of people who were very generous with their time for this episode, so special thanks to Mark Weber, the Computer History Museum, Thierry Bardini, Bjorn Hartman, Eugene Eric Kim, Joe Blaylock, James Yarchenko, Glenn Fleischman, Harvey Laitman, Martin Hardy, Carolyn Rose, Laura Olberg, Wesley Willett, Fred Turner, and Brian Crabtree for their help researching this story. You can find the show and like the show on Facebook. I tweet at Roman Mars. If you follow me at one of those 2 places, you'll be aware of all the talks and events that we have coming up. We have a cool Tumblr, and our Spotify playlist will make you feel like you're living inside of a 99PI episode. But I encourage you to explore the entire world of 99% Invisible at 99pi.org. Radiotopia.